Okay, now let's do this same concept just with monomials. So with variables, but not with polynomials. So they're not adding or subtracting. So what we're going to do is same concept. I'm going to take this 4. I don't really have to do a factor tree since I know 4 is 2 times 2. So I'm going to write this as 2 squared, that's 4, x squared y to the 5th. Okay, now let's do this one. The 6, break it down, it's 2 times 3, x to the 4th, y cubed, z to the 6th. Okay, we compare each factor. In between the two, we choose the higher amount. So the first factor is 2. Here's 2 squared. This one just has 2. So 2 squared is the higher amount. We want to use 2 squared. Okay, now look at the 3. There's a 3 on the red group of numbers, but over here on the left, it did not have a 3. Choose the higher amount. We want to use this 3. Now compare the x values. So I have x squared, and I have x to the 4th. Choose the higher amount between the two. That's x to the 4th. Okay, now let's compare the y's. Y to the 5th is on the left, y cubed is on the right. The higher amount is y to the 5th. Okay, next up is the z's. Z to the 6th is on the right. There's not any z's on the term from the left, so we have to use the higher amount, which is z to the 6th. So now if you go ahead and do this part, 2 squared is 4 times 3, that's 12. X to the 4th, y to the 5th, z to the 6th. That will be, if we're adding these, we were doing a fraction where these are the denominators, that would be our lowest common denominator. Okay, let's do some more. All right, so break up your 6. Your 6 is 2 times 3, x to the 7th, y to the 4th, z. Okay, think about your 15. Your 15 is 3 times 5, and then x squared, y cubed, z to the 5th. Okay, so remember, we're comparing each one, and we're looking for the higher of each factor. So start with the factor of 2. Over here from the 6, I have a factor of 2. I don't have one on the 15. So it happens one time. That's the most it occurs. I'm going to write down 2. Now compare the 3's. Each one has a 3. It's tied. They each have just 3, not 3 squared or anything. So I'm going to use a 3. I'm just going to underline it from one of them. Now look at the 5. The 5 comes from over here on the 15. There's not a 5 on this one. So the higher between the two is just this single 5. It does occur. Okay, now look at the x's. I have x to the 7th and x squared. The one with the higher power is x to the 7th. That's the one I'm going to use. Okay, I have y to the 4th and y cubed. The higher power is y to the 4th, so I'm going to use that one. Then I have z and z to the 5th. The higher power is z to the 5th, so I use the one that is larger, that has the higher power of each factor. So you can multiply 2 times 3 times 5, and you're going to get 30, x to the 7th, y to the 4th, z to the 5th. Okay, let's look at this one. On this one, I have x cubed, y to the 7th. There's no number in front, no coefficient, so I'm not going to break anything up. Okay, I am going to break up the 8. The 8, I'm just going to jump out to the side and make my factor tree if I need to. And I find out 8 is 2 cubed. So I'm going to write it that way. I'm going to have 2 cubed, y to the 5th, z. Okay, compare them. The first factor is 2. The one on the right-hand side here, 2 cubed, is the only place that 2 happens. 2 was not a factor over here. So I use the highest between the two. This one doesn't have one. This one has 2 cubed. 2 cubed is definitely the highest. Now compare the x's. There's an x cubed right here. The other monomial does not have x's, so I have to use x cubed. Compare the y's. There's y to the 7th and y to the 5th. The higher one's the one you choose, y to the 7th. Okay, compare the z's. There's a z here. There's not one on the other factor, so this single z is the higher one. So 2 cubed is 8, x cubed, y to the 7th, z. That is what's called your least common multiple, which is what we would use when trying to find a least common denominator. Okay, so on this one, I'm going to start with 30. I'm just going to use some space out to the side to make our factor tree. I know it's 2 times 15 and 3 times 5. So I'm just going to write this down as 2 times 3 times 5, x to the 4th, y to the 7th. Okay, let's do the exact same thing with the 8. I'm just going to use the space over here. And if you are like, man, I know 8 is 2 cubed. Awesome. Don't do the factor tree then. Just write it down as 2 cubed. Okay, so we have x squared, z to the 8th. Okay, so you're picking each factor, you're comparing it, and you're choosing the highest amount of each one. So look at the 2's. On the left, I have 2. On the right, I have 2 cubed. 2 cubed is definitely the larger amount of 2's, so 2 cubed. Okay, look at the 3's. I have a 3 on the left. I don't have any 3's on the number on the right, so I just have the 3. Okay, compare the 5. I have a 5 on the left. There's no 5's that came from the 8x squared z to the 8th, so I just have that 5. Okay, compare the x's. X to the 4th and x squared. X to the 4th is definitely higher. Use x to the 4th. Compare the y's. Y to the 7th, and then no y's. Y to the 7th is definitely higher. Compare the z's. Z to the 8th, and then on no z's on the left one, we need to use z to the 8th. So I'm going to multiply this. Feel free to use your calculator to do that. And so we're going to have 120, x to the 4th, y to the 7th, z to the 8th. And I promise you this will have much more of a point as we get into actually doing this with our rational equations in our upcoming section.